are going to start with the next part of organic nitrogen compound. कहाँ तक हम लोगों ने किए थे? Last time I think we were on diazotization. Okay, diazotization. So let me draw the structure for you. Coupling reactions कर रहे थे हम लोग. Oh, very conversation last time. Yeah, we did it, but I did not make it for you. I have given you the work, but most of the students they did not send me. So that's why I'm making. So this is the diazonium chloride. N positive, triple bond N and Cl minus, and this one is going to react with. यहाँ वाली चीज जो है वो that would be little bit different. Okay, so I told you that with benzene this is carbon and this is hydrogen. So this H and this Cl. So they are going to form HCl. So you will get HCl, and the rest of the things they would join like that. This is benzene. This is N double bond N, and this is another benzene O minus, and this is CH3. So this structure that is called as the aniline yellow. Okay. The next one, you should make the. This is the previous lecture thing. I'm going to make it for you. I have given you to work on it and draw it. So most of the students they did not send it to me. So N positive, triple bond N, Cl minus, and this one benzene, and this one is NH2. So I told you the side chain of the benzene that does not react with diazonium chloride. This is diazonium chloride. The diazonium chloride always react with the carbon and hydrogen present on the corners. Okay, so carbon and hydrogen up here. So H and Cl, they are going to form HCl, and rest of the things you have to join them. So this is benzene. It got nitrogen double bond N, and this is another benzene. Okay, so this structure that is called as this is actually the orange dye. This dye is also named as azo dye. Okay. The next one. This is benzene, N positive, triple bond N, Cl minus. So this is NH2 and CH3 up here. So again, this Cl would join with the hydrogen of this corner. So it is going to form HCl and join rest of the things. Benzene, N, double bond N, benzene, okay, NH2 and CH3. So this one that is called as the red dye. Okay. And one more thing. So up here that is SO3 minus Na positive. Okay, so this one would join with this one. So this is SO3 minus Na positive. So this one is called as the sunset yellow. So these are the different dyes. Okay, I had made it for you. So keep remember that whenever disonium chloride it reacts with any benzene related compound, it is going to form a dye. All the colors which you see, the colors of the clothes, the paint color, all these colors they are made up of disonium chloride. So disonium chloride is the starting material for any color to be made. Okay. Okay, guys. So now we are going to start the reactions of amines. Okay, my dear students, amines basically they are acting as a base. Uh, Amines, they just like ammonia, they are the proton acceptor. Okay, so they are called as the bases. So they are used as bases. So we got the two different compounds. Let's suppose this is CH3NH2. This is amine. Okay, and we got CH3 C double bond O and NH2. So this is my dear amide. Always keep remember the amines, they are always basic in nature. They are proton acceptor. Proton acceptor. Whereas the amide, they are always neutral. Why they are neutral? Because for accepting the proton, the nitrogen should have the lone pair available. Okay. असल में इसमें होता क्या है? If you look up here, CH3 ये NH2 है, तो नाइट्रोजन के पास लॉन पेयर होता है, तो ये अपना लॉन पेयर इस प्रोटॉन को देके और इसको अपने साथ जो है वो ज्वाइन कर लेता है, तो प्रोटॉन एक्सेप्टर बन जाता है। ठीक है। जबकि ये अमाइड के केस में क्या होता है कि ये सी, ये ओ और ये एन है, इसके पास नॉन पेयर है और यहाँ पे डबल बॉन्ड है। तो होता क्या है कि ये जो इलेक्ट्रॉन इसका है ये इधर डीलोकलाइज हो जाता है, ये इधर डीलोकलाइज हो जाता है, तो यहाँ पे डबल बॉन्ड आ जाता है, यहाँ पे डबल बॉन्ड खत्म हो जाता है, ये नेगेटिव हो जाएगा। ठीक है जी। और उसके बाद फिर ये जंप करके इधर, तो ये ओ और एन के बीच में जो है वो इलेक्ट्रॉन्स आपके जो है वो मूव करते रहेंगे, तो नाइट्रोजन का जो लॉन पेयर है वो इट इज नॉट अवेलेबल टू हिम, तो इसीलिए ये प्रोटॉन को एक्सेप्ट नहीं कर सकता, दैट इज व्हाई इट इज न्यूट्रल। तो पेपर में ये क्वेश्चन जो है वो उसने पूछ लिया हुआ है। जरूरी नहीं कि जहां पे NH2 ग्रुप लगा हो दैट इज बेसिक। NH2 group, if it is attached with C double bond O, that is a neutral. It is amide, it is neutral. It's not basic. Basic कब होता है? When NH2 group is attached with some carbon and hydrogen chain. Carbon के साथ attach हो, does not have C double bond O. ठीक है जी। तो हम लोग पहले इससे रिएक्शन जो है वो कर रहे हैं amines as base. So amines as base. So I'm going to take the example of the three different amines. सबसे पहले मैं primary amine दे रहा हूँ. In the primary amine, what you have got CH3 and NH2. नाइट्रोजन के साथ दो हाइड्रोजन लगे होते हैं, तो ये प्राइमरी अमाइन है। If you are going to react it with some acid HCl, so what will happen? It is going to accept the hydrogen from this acid to become CH3 and NH3 positive Cl minus. Okay, so this salt that would be formed. So this is the primary amine. Then you got the secondary amine. Okay, in the secondary amine, CH3, NH, and CH3. The nitrogen has got just one hydrogen. Two of its sides are having the carbon, so this is called as the secondary amine. The secondary amine also act as a proton acceptor. ये भी क्या करेगा कि इस H को अपने अंदर accept कर लेगा, so it would become CH3 NH2 positive Cl minus and this is CH3। तो ये भी आपका जो है वो सॉल्ट बन जाएगा। तो ये देखें जिस तरह ये इसमें ऐड होके ये NH2 था तो ये NH3 पॉजिटिव बन गया और साथ Cl। इसी तरीके से ये H इसमें ऐड होके दिस वन टू बिकम NH2 पॉजिटिव Cl माइनस और साथ वो CH3 आ गया। एंड देन द थर्ड वन दैट इज टर्शियरी अमाइन। In the tertiary amine, the nitrogen is surrounded by the carbons on its all sides. It does not have any hydrogen. This is the tertiary amine. In the tertiary amine, the same rule would be applied. This H would be gained by this nitrogen. So it would become CH3, NH positive, Cl minus, and this is CH3 and CH3 as well। तो तीनों केसेस में देखें कि उसने हाइड्रोजन को एक्सेप्ट किया और अपने साथ ज्वाइन करके यहाँ पे दो हाइड्रोजन थे so it would form NH3 positive। This one is having one hydrogen so it accepted one H positive to become NH2 positive। और यहाँ पे कोई हाइड्रोजन नहीं है so it accept one hydrogen to form NH positive Cl minus। तो तीनों केसेस में आपके सॉल्ट जो है वो फॉर्म हो गए हैं। ओके, the next thing, phenylamine is also acting as a base। So this is phenylamine। Benzene NH2 group is attached, so it would react with the HCl, so H would be gained up there, so it would become benzene NH3 positive and Cl minus। Okay, so this is also acting as a base। So you got the primary, secondary or tertiary amine or phenylamine, all are acting as a base। Is it clear, my dear? Yes। Okay guys, now the reactions of phenylamine। Phenylamine with respect to benzene group। So the reactions of phenylamine with respect to benzene group, they are exactly same as the phenol। Okay, so the first reaction I am going to do with the bromine। So this type of the reaction we have done in the phenols as well। Why? Because the phenylamine, the nitrogen has delocalized its lone pair to the benzene ring, due to which the reactivity of the benzene it has been increased। So if you react it, my dear, with the bromine and that bromine is non-aqueous, it's not dissolved in the water. So what would happen? No need to use catalyst AlCl3, no need to use it। Okay, so what would happen? This is phenylamine। Okay, so either the bromine would be attached on position 2 or it would be attached on position 4 like that, and HBr that is being produced। Or if you react the phenylamine with the aqueous bromine, so bromine, if it is aqueous, it is dissolved in water, so no need to use the catalyst। Why? Because the reactivity of the benzene has been increased due to delocalization of its lone pair। Okay, so what would happen? The bromine would be attached on the 3 positions, position 2, position 4 and position 6, and 3 HBr they are being formed, and this whole thing, my dear students, that would form the white precipitate। अगर बेंजीन की 2 या 3 जगहों पे ब्रोमीन लग जाते हैं तो वो चीज व्हाइट प्रेसिपिटेट बनाती है। तो इसके जो रिएक्शंस हैं ब्रोमीन के साथ और नाइट्रिक एसिड के साथ वो बिल्कुल सेम है जिस तरह फिनोल में थे। ओके, Okay, guys, so we are going to start with the next reaction, that is with nitric acid. Okay, so HNO3, this is dilute nitric acid. With dilute nitric acid, concentrated sulfuric acid shouldn't be used as a catalyst. Why? Because I told you that the reactivity of the benzene has been increased, so no need to use the catalyst. If alone benzene or methyl benzene is present, then we use the catalyst with alcohol, sorry, with phenol and with phenylamine. With the amine group, the lone pair are delocalized, so no need to use the catalyst. So the NO2 group that would be attached on position 2 or 4, and H2O that is being generated. But if you got the nitric acid concentrated, okay, so the NO2 group would be attached on the 3 positions like that. On 3 position with 3 water molecules. Okay, guys. Now I have taken the 3 types of the things up here. This is phenylamine. This one is attached with the carbon and hydrogen chain NH2. So this is actually the alkyl amine. And this one that is ammonia. So normally in the papers, he's gonna ask you about the strength of different bases. Okay, so which base is more strong, which one is least strong. Okay, so keep remember, my dear students, everybody just listen. सबका ध्यान करो, 2 मिनट के लिए सुन लो. ये देखिए जी, इसने अपना नॉन पेयर जो है वो बेंजीन रिंग को डीलोकलाइज कर दिया है. इसके पास नॉन पेयर लेस रेडिली अवेलेबल है, यानी चक्कर काट कूट के इसके पास आते हैं लेकिन लेस रेडिली अवेलेबल है. तो अगर किसी भी प्रोटॉन को एक्सेप्ट करना है तो ये लॉन पेयर उसको देके उसको अपने साथ ज्वाइन करना पड़ेगा. तो इसका जो लॉन पेयर है वो तो बेंजीन को डीलोकलाइज होके चक्कर काट कूट के इसके पास आता है. So that is why, my dear, it hardly accepts protons. So this one is the weakest base. ये सबसे वीकेस्ट बेस है. और उसकी रीजन क्या होती है? द लॉन पेयर ऑफ नाइट्रोजन is delocalized and less readily available. So it hardly accepts protons. H positive ion. ठीक है जी, so that is why it's the weakest base. Okay, now come towards the alkyl amine. एल्काइल अमाइन में क्या होता है कि ये जो एल्काइल ग्रुप होता है इसको हम कहते हैं इलेक्ट्रॉन डोनेटिंग ग्रुप. ये इलेक्ट्रॉन को डोनेट करता है टुवर्ड्स द नाइट्रोजन. नाइट्रोजन के पास लॉन पेयर पहले से भी है और एल्काइल ग्रुप से भी इलेक्ट्रॉन अपनी तरफ अट्रैक्ट करता है. तो नाइट्रोजन को लगता है कि मेरे पास तो इलेक्ट्रॉन बहुत ज्यादा है, तो ये क्या करता है कि इजीली किसी भी प्रोटॉन को अपना लॉन पेयर देके उसको एक्सेप्ट कर सकता है. सो दैट इज व्हाई इट्स अ स्ट्रॉन्गेस्ट बेस. तो सबसे स्ट्रॉन्गेस्ट बेस वो होती है मेरे बच्चों जिसमें NH2 कार्बन और हाइड्रोजन की चेन के साथ लगा हो. जिसमें बेंजीन के साथ डायरेक्ट लगा हो वो वीकेस्ट होती है, क्योंकि बेंजीन इलेक्ट्रॉन विथड्रॉइंग ग्रुप होता है. नाइट्रोजन के लॉन पेयर लेस रेडली अवेलेबल रहते हैं जी. ठीक है, द एल्काइल ग्रुप is an electron donating group due to which the electron density of nitrogen increases, so it easily accepts protons. So it is a strongest base. Okay. और अमोनिया जो है ये मीडियम बेस होती है, इसमें नाइट्रोजन के साथ हाइड्रोजन लगी हुई है जो ना तो इलेक्ट्रॉन डोनेटिंग है और ना ही इलेक्ट्रॉन रिपेलिंग है। ठीक है, तो इसलिए ये मीडियम बेस आती है। तो अगर स्ट्रेंथ ऑफ बेस वाइज हम लोग बात करें तो सबसे जो ज्यादा स्ट्रॉन्ग होगी वो बी होगी, दूसरे नंबर पे आपकी सी आएगी और तीसरे नंबर पे आपकी ए आएगी। तो फिनाइल अमाइन जो है वो दैट इज द वीकेस्ट बेस। ओके।